Okay, so I'm gonna start over for those of you who are in class for the review. So the first three questions on the review are finding the domain of the function. So number one was f of x equals 14 over x plus 5. So whenever you're finding the domain of a rational function, remember you just need to know where the domain is. Can't equal 0. So obviously here, x plus 5, if it equaled 0, then x would equal negative 5. So the domain of this function is everywhere except negative 5. So to state that in interval notation, we would say it goes from negative infinity to negative 5. And then there'll be an asymptote there, so it skips that. And then it picks back up over on the other side of negative 5. And then goes to positive infinity. So that would be the domain of number one. Number two, same type of question, different function. Now we have x minus 9 over x squared plus 5. Now this time we run into the fact that it's squared, right? So if I set this equal to 0 and I tried to solve it, I would end up with x squared equals negative 5, right? But the problem here is if I actually tried to solve it and went to take the square root of both sides, I'm taking the square root of a negative number, which I know in a real plane is not possible, right? That's going to give me the square root of 5i. So this one, the denominator is never 0. So if the denominator is never 0, then I don't have an exclusion like I did on number one. So the domain on this one would be all real numbers, or if you want to state it in interval notation, it would be negative infinity to positive infinity. That's number two. Number three, one more of these. We have x minus 3 and x plus 4. And all of that is going to be over x squared minus 1. Okay, so on this one, again, where does the denominator equal 0? So just like on the last two, if x squared minus 1 equaled 0, and I tried to solve that, I would get x squared is equal to 1. And so this time I do get an answer, right? But be careful because it's super common to make a mistake here. So I know that x could equal positive 1 or x could equal negative 1, right? Because positive 1 squared minus 1 is 0 and negative 1 squared minus 1 is 0. So this one has two vertical asymptotes. And so that was one of the ones that we saw that looked like three pieces. So to find the domain, we would say it goes from negative infinity and then hits negative 1. Right, that's from left to right. And then we have since we have an asymptote of negative 1, it picks back up on the right side and goes from negative 1 to positive 1. And it'll have some thing going on in the middle of that. And then it picks back up on the other side of positive 1 and it goes to positive infinity. So that would be the domain for number 3. Number 4, you're using limits to describe the behavior of a function at the asymptote. So number 4 gives you a function, right? So in this case, it's f of x equals 3 over x minus 4. Okay, so that's the function. And again, we're describing the behavior at the asymptote. Okay, so first of all, we know that the asymptote is going to be at x equals 4, right? Because that's where the denominator is going to equal 0. So we know because it's a rational function. I'm just going to sketch a little graph here. I don't know what the graph looks like. I mean, I can make some pretty good guesses. But we know that over here at positive 4, right, there's going to be an asymptote. So and because it's a rational function and we know that our horizontal asymptote is going to be 0 because this is just like the numerator is just a number. This is just a basic rational function, nothing funky's going on here. Technically speaking, it's a reciprocal function. So the point is like the curvy parts of the function, is it on the top or on the bottom of the x-axis, right? Here's my x-axis. So, like, I want to know, like, is it up here and down here, or is it the other way around, right? Is it up here or is it down here? That's what you're trying to figure out. So the easiest way to do that is just pick a number on each side of 4. So like, for example, I could just use 3, right? I know 3 is right here, and I just need to know, is the graph going to be up here or is it going to be down here? So all you have to do is take a 3, plug it into your function. So 3 over 3 minus 4, right? I just put a 3 where the x was. And obviously that's going to give me a negative number, right? Because I get 3 over negative 1, which is negative 3. So that means that on, let's see if I can get it to erase pretty without erasing everything else. Oops. Why won't that eraser stay? I don't like that. I need to figure out how to fix that. We know that at 3, that we ended up with a negative number, so this part of the graph is going to be down here somewhere, right? Again, don't know exactly where it's at, but we know it's going to be negative. So I'm going to guess that the other side's positive, but again, if you would like to go check, you're more than welcome to do that. I'm going to do that. So like, I'm going to use 5, right? So 5, I'm going to use a different color. So 5 would be like on this side of 4, right? So again, we want to figure out, is it on the top or the bottom of the x-axis? So if I did 3 over 5 minus 4, that just gives me 3 over positive 1, which is a positive 3. So since it's a positive number, we know that this side of the graph is going to be up here somewhere. My lovely picture. So sort of basically, that's what my graph looks like. Now what the question is asking is for us to describe it using limits as it nears the vertical asymptote. Okay, so let's remember what that looks like. So the limit as x approaches 4 from the left side, and the limit as x approaches 4 from the right side. Remember, that's what that minus and plus mean on the right side of the number. So on the left side here, let's see, what options do I have here? This is fun. As it approaches from the left side, we can see that it's going down, right? It's going to negative infinity. So on the left side, as it approaches the asymptote, it's going to negative infinity. On the right side, we can see that as it approaches the asymptote, it goes up, right? So since it's going up from the right side to the vertical asymptote, it's going to positive infinity. Okay, so that's what we're looking for right there. What is that even? This is my answer to number 4. As x approaches 4 from the left, it goes down. And as x approaches 4 from the right, it goes up. So that's number 4. Okay, number 5.